line up, like line up at the door. That would be a permutation. How many ways can I line up 5 people at the door? That would be a permutation. And then we did combinations. Keyword for combinations: group, team, go team, and committee, of which the education system loves, because if they want something not done, they just send it to a committee. Okay, we did we go over the fundamental counting principle? Okay, this is in your unit stats and probability packet, the back of page 1. You want me to stop and wait for you to get it? STDs, students. Okay. Students abbreviated, STDs. Okay, all right, let's go. Did we go over this symbol? Okay, that symbol is the factorial symbol. Okay, the factorial symbol means if I have something like 5 factorial, that equals 5 times 4 times 3 times 2 times 1. Okay. What else did we talk about? The formulas for permutations is n factorial divided by the quantity n minus r, r being the number of if I didn't want. I do have issues. Oh, he's got more issues than I do. Okay, r is like the number of it's the actions. Okay, it's like I'm going to take 3 clubs out of 13 clubs. That action of the 3 clubs. What? Yes. If it's 6 factorial, it's 6 times 5 times 4 times 3 times 2 times 1. You could deal with, yes, you will be dealing with hundreds of factorials. However, are you going to sit there and manually, like at the college level, manually multiply out 100 factorial? No. You have a factorial key in your calculators. In fact, quiet. In fact, you won't even be doing these formulas manually because these formulas are in your calculator. At this level in Algebra 2, we are just going to use our calculators. All right. Fundamental counting theorem principle. Okay, fundamental counting principle is come up and get one, is a permutation. So when you come upon a problem like number 1, you could use the permutation. Okay, this is a permutation because order matters. You're going to go see dinner, then see a movie. So you're going to take the permutation of 5 5 total, right? Total 5. And then you're going to go to one of those restaurants, so that's your choice, 1 out of 5. Then you're going to multiply to the permutation 7 total, and you're going to choose 1 out of those 7. Okay, permutation is your order matters, like lining up at the door. Like if I want 5 students lined up at the door, how many ways can I line up those students? Okay, that's permutation. Okay, if I wanted to pick a group of students, that would be a combination. That's I'm choosing 1 out of 5. Suppose I wanted to go out to dinner twice before a movie, then that would be a 2. So that's like your choice. Okay. All right. So as we put these in our calculator before the SAT test, we found out that permutation 5-1 was 5 times 7, which equal, we had 35 ways of figuring this out. Now, again, a permutation is also a fundamental counting principle where we could have just taken 5 times 7 different ways of figuring this out to get 35. So this would be the fundamental counting principle. This would be the permutation way. And permutations. Fundamental counting principle just gets, you don't know when to use it. Permutation, you have to, when you figure out it's a permutation, just use the formula. So you have to be aware of this because it's on your SAT test, wasn't it? Fundamental counting principle yesterday. Huh? All right, number 2. Number 2. How many? Oh, we didn't even have to figure out what this was because it said how many permutations, right? So we know that this was a permutation. And it says combination if each combination has 3 numbers, no 2 numbers of any combination are equal, and the lock has 25 numbers. So the total was 25 numbers, and then we had 3 numbers as our choices, right? So you put this in your old calculator's. Okay, permutations was under math. Scroll over to prob. And on this calculator, it's number 2. Hit enter. And then we had 25. I think I should have put the 25 in first. Put 25 in first, then hit your permutation, and then 3, and enter. And you get 13,800. Right? Now, again, you could have used the fundamental counting theorem, right? Principle. I keep calling it theorem. I don't know why. If you use the fundamental counting principle, you would have taken 25. Your second choice would have been 24 out of 25 numbers, right? And your third combination times 23. You should get 1,800. Okay? Either way you're going to be good to go. Permutate, just stick with the permutation. Okay? Not anymore, unless you go into statistics or politics, any kind of anything to do with statistical work, counseling, because you're going to do a lot of surveys, you know, a lot of the, hey, ladies. Shh, quiet. A lot of the soft sciences use statistical work. Social work. I've helped my wife with a ton of her research. She's a therapist, yeah. Okay, to be or not to be? That is a question. To be. What if the lot can have repeated numbers in the combination? Well, then you're going to have to do them individually. So you're going to have to do permutation of 25 one choice times the permutation 25 of another choice times the permutation 25 of the third choice. Now, you can put this all in your calculator at the same time if you're careful. So, 25, go back to probability, permutation, 1 times 25, math, probability, permutation, 1, times 25, permutation, 1, and hit enter, and you get 15,625. Or, this one actually, the fundamental counting theorem would have been easier. 25 times 25 times 25. Okay? Number 3. How many 6-digit license plates can be manufactured? Okay. Okay, let's figure this out. 6-digit license plates. 1, 2, 3, 4, 5, 6. There's my 6 digits. What are my digits that I can use? And 0. Yeah. So my digits I can use, 0 through 9. How many digits is that? 10. So my first choice, I have no restrictions, right? So I can use 10 digits. My second choice, I can use what? It doesn't say I have to throw it out once I use it, does it? So I could keep using them, right? I could have 0, 0, 0, 0, 0, 0, right? So I could have 10 choices, right? You've never seen a 0 on a license plate. Yours is going to have like double 0. That's going to be your license plate, 0, 0. That's why we use 0. You can only think about, you can only have single digits on your license plates, right? You can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 digits. There's 10 choices for each digit. Okay? Doesn't say once I use on this particular question. The next question does, but not this one. Doesn't say once I use a digit, I can no longer use it. So every choice, I have 10 digits. Or, you know, you're going to end up with a license. You could end up like a license plate like Clayton's there, where you got 0, 0, 0, 0, 0, 0. Like a loser, right? So each choice, you could have 10. Okay? This would be a really good fundamental counting principle to use. 10 times 10 times 10 times 10 times 10 times 10, 1 million. Okay? That's how many choices I have for this particular problem. Wow, I recorded that. I could get in trouble for that one. Okay, number 3B. Okay, what if no license number can begin with 0? So I still have my 6 digits, right? 1, 2, 3, 4, 5, 6. So the first one, I can't use 0, so Clayton can't get a license plate. I can't use 0 for my first digit. So how many choices do I have for my first digit? 9, because I can't use 0 for my first digit. And then no digit can be repeated. So, I don't know. Okay, so, I can't use 0 for my first digit, so that gives me 9. Shut up. Caleb. So I can't use 0 on my first digit. That gives me 9 digits to use, 1 through 9. Now I can't use any repeated ones, but now I can use 0. So I wiped out one of the digits for my first choice, but then I'm going to add back 0 for my second choice. So how many digits do I have? How many? 9. Right. Okay, so now that I've got 2 digits used, what about my third one? 8. Oh, man. This is why teachers can't carry guns.
Okay, but we're paying attention. So, like, no. Hey, D, your suspenders twisted.
I know somebody really told me that. I think I might have to actually take it off. Okay. Shut up. I am not. Shut up. 1, 2, 3, 4, 5, 6. Shh. My first digit. I can only use 1, 2, 3, 4, 5, 6, 7, 8, 9. How many is that? 9. My second digit. I now can add in 0. 1. So what do you want the digit to be the first choice? 3. Okay, so 3. So we're doing an example. 9 choices, we chose 3, the number 3. So I have to cross that out because I can't repeat. Okay, so my second digit, I now can add in 0 because it's not the first digit anymore. I have 1, 2. I can't use 3. 4, 5, 6, 7, 8, 9. How many digits is that? 9. Took out 3. What do you want the second digit to be? 5. So we're going to cross out 5 because we can't repeat. Got it? Got it? Right. It says you can't repeat. Okay. Put that in your calculator. What do you get? Use a fundamental counting principle. 9 times 9 times 8 times 7 times 6 times 5. 136,080. $136,080. Those are the choices you have. Didn't think it would be this hard. What? I'm what? Number 4. This is the last one I'm doing because I'm really tired. Oh, okay. You guys want your quiz? All right.